Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here coming up with another fantastic chemistry video, and today we're going to talk about assigning formal charges. Now, this is a big deal. This is an important concept in organic chemistry. It's important that you can do it, and you can do it relatively quickly when you're working on chemistry problems. It's not hard, and eventually you're going to start recognizing patterns, but you have to know how to do it. Now, it's very simple. There's a couple of ways to do it. I have my way. Your faculty member may have their own way. As long as you get the right answer, I really don't care how you do it. But here's how I do it. I say, okay, I look at a molecule like that, and I say, okay, how many valence electrons does neutral hydrogen have? And neutral hydrogen has one valence electron. Just remember that. Neutral hydrogen has one valence electron. How many valence electrons does oxygen have? Neutral oxygen, I should say. Well, that has 6, right? It's in group 16. Neutral oxygen has 6 valence electrons. Okay. Then I say, okay, well, how many does this hydrogen have? And the rule here is you count every bond as 1 electron. Count every bond as 1 electron. Now, when you're doing octets and Lewis structures, every bond counts for 2. When you're assigning formal charge, just consider every bond as 1. Because remember, the hydrogen and the oxygen are sharing it. Hydrogen brings one, oxygen brings the other. Okay? So here, I have 1 bond to hydrogen. So the hydrogen has 1 valence electron, if you want to think of it that way. Okay? So that means the hydrogen doesn't have a formal charge. There is no formal charge on hydrogen in this ion. However, oxygen normally has 6 valence electrons. Normally has 6. That's neutral oxygen. Group 16 or 6A, 6 valence electrons. Neutral oxygen has 6. This one, however, has 2, 4, 6, and a bond. That's 7. So the oxygen here is negative. The oxygen here is negative. Now, you guys knew this is hydroxide. You guys all knew it was negative. But that's how I figure it out. I think to myself, how many valence electrons does oxygen have? The answer is 6, neutral oxygen. In this particular Lewis structure, though, 2, 4, 6, and if I count the bond as 1 electron, that's 7. 7 electrons. So that's 1 more negative than normal. So it's negative 1. And that's how you do it. So count every bond. When assigning formal charge, count every bond as 1 electron. When counting Lewis structures, they count as 2 because they are 2. But when you're assigning formal charge, just assign 1 electron per bond. Over here. Now, hydrogen doesn't have any formal charge in this case. Hydrogen has 1 bond. As long as it has 1 bond, there's no formal charge. However, oxygen normally has 6 valence electrons. Let's count. 2, 3, 4, 5. So here the oxygen has 1 less valence electron. It's supposed to have 6, and it only has 2, 3, 4, 5. 5 valence electrons. So that means it has 1 less negative than it's supposed to have. It's supposed to have 6. Has 1 less. So this one is positive. The oxygen in this case is positive. It's supposed to have 6 to be neutral. If we count it, it only has 5. Therefore, it's positive. The formal charge on oxygen is positive. All right, let's go to the next one. Boron. Boron is in group 13 or 3A. Boron normally has 3 valence electrons. That's normal boron. Normal being neutral boron. Here, if we count every bond as 1 electron, 2, 3, 4. Here it has 4 valence electrons. So it has 1 more electron than neutral boron. It has 1 more negative. So that means the boron in this case is negative. The boron in this molecule, in this ion, is negative. Easy enough, right? Moving right along. Nitrogen. Nitrogen has 5 valence electrons. It's in group 15 or 5A. So it has 5 normally. That's neutral. But here, again, count every bond as 1. The nitrogen has 4 valence electrons. That means it has 1 less negative charge than it requires to be neutral. So this nitrogen must be positive. Now that's how you assign formal charge. It's a very important skill that you can recognize. Now, eventually you're going to see bonding patterns. You're just going to see the same bonding pattern over and over again, and you're going to your mind's just going to go to the charge. But for now, you have to learn how to do it, and you have to have something to fall back on an exam in case you forget. Now, this is very simple, but necessary to practice. All right? Okay, guys, if you found this video helpful, please go ahead and slap that like button. Leave a comment below. Let me know how I can help you in your organic chemistry career. Maybe I'll make a video just for you. And if you could, please consider subscribing to my YouTube channel. It really does help me out. It keeps me encouraged to make more and more content for you guys. It also tells YouTube that I'm doing a good job, and it may recommend my video to more people so I can reach more people, help more people to be successful in this chemistry that I love so much. All right, guys. Now, with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.